The biggest way that we make use of the properties of real numbers when we're doing algebra is to do what's called simplifying an expression. So let's recall what this means. So an expression is something we write that represents a number. So it can have numbers, it can have variables, it can have symbols for operations. Any sequence of symbols that represents a number, that's an expression. To evaluate an expression means to determine what number it represents, right? To work out the arithmetic. If there are variables in the expression, we have to know what numbers they represent first. Two expressions are equivalent if they represent the same number, no matter what the variables represent. We talk about rewriting an expression to mean writing an equivalent expression that looks different somehow. To simplify an expression is to write an equivalent in some standard simplest form. Throughout this course, we're going to be meeting new kinds of expressions, and one of the things we're going to say is, what is the simplest form of an expression of this kind? When we talk about the way that we manipulate expressions, sometimes we need names for the parts of the expression. The terms of an expression are the parts combined using addition. The factors are the parts combined using multiplication. So if two pieces are multiplied together to get our expression, those are factors. If two pieces are added together, those are terms. Of course, subtraction is just adding something negative. So subtraction also splits up terms, but the negative side belongs to that term. There are a number of things we can do to simplify an expression, right? We can simplify a fraction, cancel common factors in the numerator and denominator. We can use the commutative property to rearrange terms or to rearrange factors within a term. We can just multiply numbers within terms. We can use the distributive property to eliminate parentheses that are around addition or around subtraction, since subtraction is just addition in disguise. We can make this move called combine like terms, which uses the distributive property and also a little bit of the associative property in there. And then we can use properties of exponents to combine factors, which we'll talk about some more later on. So if we meet this expression 3 times x plus 4 minus 5 times x minus 3, and we want to simplify it, right? So we'll have 3 times x plus 4. This negative sign belongs to this term. So we can think about this as plus negative 5 times x minus 3. Here we have one term, two terms, each of which contains parentheses. And I wanted to rewrite this as plus negative 5 so that I could clearly see that my subtraction was just representing adding the opposite. So within each term then, I can use the distributive property, right? We'll distribute 3 times x plus 3 times 4 is 12 plus negative 5 times x plus negative 5 times negative 3 is positive 15. And why can I do that? What I'm doing here is applying the distributive property. And notice that now that I've eliminated those parentheses, I have 1, 2, 3, 4 terms. And ultimately what I'm going to want to do is combine like terms. Just to make it easier to see what I'm doing, I'm going to switch the order of these two terms. So I'll have my 3x minus 5x plus 12 plus 15. And the reason I could do that was I was applying the commutative property to reorder the terms. But now it's easy to see that I have two pairs of like terms here, right? My 3x minus 5x, those two have x as their only variable. I can combine those by subtracting the coefficients, and I'll get negative 2x. And then I also have 12 plus 15. Those terms don't have any variables at all. So 12 plus 15 is 27. And that was just combining like terms. So that original expression simplifies to negative 2x plus 27. Now, I've written out not all of the gory details, but a lot of the gory details of this process. If I were just doing this, right, if I met this problem in the wild or wanted to simplify this as part of a larger problem, I would probably only write that step where I've distributed and then just the final result. I wouldn't necessarily write out the details of rewriting subtraction as adding the opposite or the details of rearranging the terms. I would do that if I had a big complicated expression and I found that I was losing track of things. In general, the more complicated the expression, the more details we want to write because we don't want to be trying to keep track of too much stuff in our head. But if you were to be doing this problem and you just wrote the step where you distribute and then the final result, that would be fine.